It'll also be quite interesting to have a discussion at the end to see who's actually mobilising back to the site and if there's any movement. I think there's a lot of construction companies already back working. So it'd be interesting to have a group discussion to see when the industry's ready for it. So today we're going to talk about the key stage inspections, and these key stage inspections will be on any type of sport surface. They can apply, the principles apply, and we'll discuss that through the presentation. Okay, so hopefully everyone can see the screen, the PowerPoint presentation. You should be able to see a person on site doing a PRIMA test. I think that one's at Kilmarnock. And what we're going to discuss today is the steps in the process, and how you can utilise that in any project planning or cost planning. So what we've got is we've got a portal here where you can ask questions, you can communicate with us, you can also leave questions in and we can come back to them at the end. We can also unmute you, so you can verbally have a communication through the presentation at the end, so that's an option as well. So what we're going to do is we're going to record this session, and then you can all go back and look at it at a later date or share it if people can't join us today. So my background is I'm a sports engineer. I've worked in the sports and construction industry since I came out of university. I've worked down in England, I've worked up in Scotland, and now my role is more in the business. But today we're going to look back at the actual construction tests and what we do as a company and why we do them. Sports Labs, the company, was founded 20 years ago by chartered civil engineers. So everything that we use when we talk about key stage inspections has derived from the roads construction industry. So all these tests and protocols are somewhat utilised for many, many years before we have. Although the construction might be different, they're still applicable to what we want to use it for. Okay, so the construction key stage inspections and the process we're going to talk about today, we're going to go through what we would call them phase 1 to phase 5. I've put them in an order to help, I suppose, me understand them and everyone else. The site component sampling, the reuse of existing shock pads or E-layers. I call this a KSI because it's quite important that people know it's obligatory if you want a new FIFA resurface or a hockey pitch or a World Rugby pitch. You have to do this process. You have to provide evidence to the governing bodies on certification. The actual test, the DCP and the LWD, what are they and why do we do them? The layer depth, something that is always overlooked in my opinion, something that can be easily checked. The drainage and infiltration, the straight edge and visuals, the ancillaries and around the site, not just the physical tests we do, but the things that we can find and advise on what needs to be done in the correct manner. Particularly with site establishment at the very first visit, is everything safe, secure and okay for people to enter the site. Lab sampling tests, what we do, why we do them. So that could be from anywhere from the aggregate material right the way through to the sand and the rubber, and the grass and all that type of material. Okay. And then we talk about test locations. I'll provide an example so you know what you should be looking to do on a pitch base. The research and development, I think this is quite good to touch at the point at the end with the LWD as well. The reason for that is there's quite a bit of development and research going on. And finally, I'll try and share some links and some data that you can read up on specific to sports construction build that we have on our website. So I suppose the most important thing is that when we go through the stages in a build, there's a lot of liability, there's a lot of risk, particularly with design and build. So it can be used by many different types of clients, from the owners of the pitch to the contractor to someone that's facility managing many different sites. The importance is it gives evidence of conformity, it gives security to move to the next layer of construction, and it gives I suppose everyone that little bit of paper that says proceed, with confidence. And sometimes when it's not done, you look back retrospectively and you ask the question, what went wrong? And 9 times out of 10, if you've done a key stage inspection test, you'll be able to find out the problem there and then. You won't have to remediate once you've got the final surface down, because that's an expensive and costly process. It's very easy to manipulate a final surface in terms of the amount of rubber, sand, and to get a surface to be compliant. But what you can't do is change the base layers easily. That's something that's very difficult to do once the final surface has been installed. We've had a recent project. It's now gone into its third refurbishment or resurface. The existing bases have very little work done, and that's because they went to the hills with the design and the testing at the time. So there's tolerances that can be applied to make sure you have confidence in that build for the future. And it's security. At the end of the day, a pitch is an asset in your business model, and you want to protect that. And if it means an extra small percentage in the build cost, then it's a very, very good step to take and to put it in the process early. Okay. We also offer the independency for testing. So I suppose the question is, why are we involved and not the contractor, or sometimes I suppose the client, they want an independent body to do the test that has calibrated and experience of testing. So that's what we offer in the process, particularly when it comes to expert witness case, when people want to track back and find out what the problem was. So yeah, and as I mentioned, there's obviously a history with KSIs, and I suppose if you look at the highway sector, they've been around for about 60 years, and it's been transferable into sports construction. What we'll do is we'll talk about the purpose of the tests. I suppose the cost differential between not doing it and doing it is a big challenge at the start. When you look at the scope of works and the budget for the client, sometimes when you value engineer a project and you take out the asphaltic layer or the macadam, it's very easy to remove the key stage inspections. But these are your security. These are what you can have on your passport of your pitch and see if it was done correctly. And I think the other thing as well is reactivity. There's always a question about reactivity. How can we get to site? How can we make sure that how can you make sure that it's done quickly, the contractor's not delayed, particularly with incoming weather fronts? Well, I think the answer to that is it's all about the laboratory that has the ability to react. So I think we try to get on site within 48 hours. The best way to go around that is to project plan. So keeping high communication. If you've got delays, which is very common, just to let the laboratory know. Okay. So what we're looking for, base stability is probably the most common problem, or the most regulated test in terms of the DCPs or the LWDs. I suppose that very simply what we're trying to do is we're trying to provide evidence and provide some practical knowledge that the site can withstand the load that's going to be exposed to, whether that's vehicles, it could be vehicles, plant machinery coming in to do the lighting columns, it could be anything. It could be before and during the installation, it could be after installation. For example, ambulances, the point loading of the wheels of ambulances are very, very high. So that's the kind of thing you need to think about. And these tests essentially say that there's no permanent deformation, and the stiffness applied to the surface can sustain the pressure applied. Okay, so we'll talk about the phases. I'll talk in summary here what the phases are. What we're looking at here is the formation layer. It's the start of the build, where you put your drainage runs in, then take your sub base, the dynamic stone, whether you've got blinding layer or it's just a one course layer. The engineer material, the asphaltic or macadam layer, and the shock pad. So is it a new shock pad, new in situ, or is it an existing shock pad? What do you do? How do you interrogate whether that pad can be reused again? And some people wouldn't consider shock pads in a case stage inspection. I would. I think it's very important we do. And finally, full process control of the sampling. So right the way through from start to finish, you can get ahead of time with certification. You can do all your identification in the lab to get your certificate very quickly after the final test. But I suppose more importantly, if the sand or the rubber or any performance info or any carpet or shock pad delivered to site is non-compliant to specification, then you find out early and you don't have to backtrack. And that protects a contractor who buys the material overseas sometimes. So that's in the process to help protect everyone. I suppose if you look at a traditional build or a design, this diagram might help understand when we talk about phases. You talk about the formation in the modified type 1 material or dynamic layer and the blinding stone, and then after that, we talk about the asphaltic layer and the macadam, and if that is not in the project, you go straight into the shock pad or sometimes the 60mm turf. So that's a brief oversight of the types of construction layers, and what we would tend to go out and look at, and also when we talk about the phases, we're going to talk about the volume of testing we look to do, and the outcome. And what I can share at the end of this presentation is we've got a basic document that gives you an idea of what you should be doing at each layer. So I can share that at the end if anyone requests it. Okay, so when we look at the formation, I suppose the formation is the first time we would generally get involved in site, unless we're a consultant on the project. So we look at the CBRs, the stability of the base to withhold or withstand the load. The levels are very important, particularly in certain countries around the world. It differs significantly to help attenuate the water or allow the water to move off site. The drainage course, the drainage runs, the laterals, the carriers, the manholes, the inspection chambers. So these are all, they start the preparation for this. And I suppose as well, it's the first time we get on site to look at site setup. The visual inspection, is the equipment and the people on site, is the containment okay. So this is probably the first time we would end up on site and we would look at all these different tests. There's also obviously a difference in practical or way people do it globally, but in the UK we've got a pretty strong system. We've got a lot of programs that follow the same systems. If you have to consider as well the type of construction, so if you look at a tennis court would generally have a lot more attention to detail in terms of the compaction, in terms of the surface level, and that's something that you need to consider. So next we'll look at the sub-base layers, so usually sometimes known as a dynamic layer, and again we will do some of the tests we did in the initial layer, from infiltration right the way through to the stability, and some of the new tests we would look at here is now probably the curbs are in. They've got a blinding layer, they've got an evenness test that we would do, and we would also check the depth. So we'd look at the depth of stone, compacted or uncompacted. Does that meet the design specification? And again, the levels. I think some governing bodies require specific gradients and tolerances on the site, so we need to make sure that that's starting to take shape and it's within tolerance. Okay, and then we'll look at the engineered base. So not all projects have these. Unfortunately, there's probably somewhat of a dying breed. We are seeing a lot of big programs starting to utilise them again, which is great, because it means your asset as a pitch or a facility will be easily transferable or resurfaced. So I think we're moving into an era where in Europe we maybe have 37% resurfaces. In the future, that's going to increase to probably somewhere in the region of 90% when we hit a threshold. So if it reaches that 90%, what pitches are pretty simply a lift and lay. I think that's where we want to be. That's what people might think they are, but when they lift sometimes the carpet, they might find a lot more problems, and the sinking fund might not extend to what they need it to do. Okay, and then once we do again the similar test evenness, we might change the type of straight edge we use in this test, from a rolling straight edge to a box straight edge, which we'll talk about a little bit later. Phase 4, the shock pad test. We consider this usually for in situ shock pads. Prefabricated shock pads are usually quite well regulated. Sometimes they're delivered with certificates of conformity or CE marked, and that's where we would do the in situ test and spend time on that, because it's a mix on site. Things can go wrong in the climate, things can go wrong with the installation technique, the equipment. So things like the thickness are very important. We take samples from site as well to do tests in the laboratory, and we would also check the straight edge, because sometimes the joints can be exposed, be high. And again, this is governing body regulated for existing pads, so you have to be aware if you're going to use an existing in situ shock pad, you have to put in your budget the tested pitch and provide that evidence to the governing body. Okay, key stage inspection 5. This is something that will run continuously through from the start to finish. So we're looking from the carpet to the seams, to stabilising performance infill, to aggregate materials, to shock pad. Any material that's taken to site, any component that's involved in the build-up of the pitch, we should look at. We should interrogate as soon as it comes to site. And the reason for that is sometimes quality control methods, or sometimes the material we think we're buying is not actually the material we get to site. That might be an unconscious mistake from the supplier. It could be other, more direct reasons, cost saving. So it's really good to have this in your remit of work. It's not a costly exercise against the value of the project. It's very, very minimal, and it gives you confidence that you're not going to have to end up in a legal dispute later down the line for non-compliant products on site. And it's good to point out as well, for everyone that's under a time pressure, if you test all this material prior to the official FIFA World Rugby certification test, there's no reason why you can't get the certificate within 24 hours. That's pre-warning and pre-planning. We've done it many, many times. We've communicated with governing bodies. I think we're probably one of the first labs to do a same-day certificate, but that's the opportunity. If you're under time pressure, you can really utilise key stage inspection and sampling at different times to do that. So what we're going to do now is we're going to go a bit more into the actual test methods and explain what they are and why they do them. And I mentioned before that the highways industry, Transport Scotland, Highways England, they use a lot of this equipment and test methodology, and that's where we've taken it from. So we've not created new test methods or protocols. We do have to evolve them for our industry, but they're set in stone. When we talk about a 5% CBR minimum expectation and the California bearing ratios and what we want from the material, we already know that from different industries. We're just applying it to our industry. I think there's an exception that we maybe don't have the same load as what a highway would have. So there's sometimes some engineering decisions can be made depending on results. But the reality is that we have systems that are great, strong, powerful, and we can use them to our advantage in sports construction. So the dynamic compedometer is very simple. You see the pictures. We're trying to find out what layer depth we are, what the performance of the material is at different layers, and that allows you to understand the design, what you can do, what you can't do, and if the base is ready for the next layer. Sometimes if you expose formation and moisture is retained in the ground, then you might have to wait for a long time to dry out. So you have to be very careful about when you open up the formation, particularly in the start to the winter months. It also tells us where the soft layers are, and if there's going to have to be some work to the soft layers or spot work, cuts and fills. Bedrock, you might hit bedrock, you might not know it's there, you might find it, which is very interesting in your arm when you're doing the test. But essentially, you can see the level of detail. You can really interrogate the graph and see what layer is where the layer changes. Yeah, this can be done retrospectively as well. If you have a problem on site and the base is moving, you can actually punch this through the top carpet. It's not advised to do that, but in extreme cases you can, and we've done that to try and find out what the problem is on site, particularly when the layers that people think they have bought and the material they've bought doesn't seem to be performing on site. You also get different performances of clays to sand and expectations. So when you're interrogating the layers, you can then start to understand what's below. So, this might tie in with your site investigation. You should probably do a lot more locations and data collection. And as I mentioned, there's a correlation to CBR, so we can look at that to give the thumbs up to move forward. I think we'll talk about next is the load bearing tests. So the fallen weight deflectometer, a big bit of kit on a lorry. You can see the amount of interaction points with the ground, and the load bearing capacity, the information it gives you, it's fantastic. But the reality is that we've moved to the lightweight deflectometer in our industry. The reason for that is data collection, reactivity, I suppose accessibility as well, and that's something that we'll talk about a bit more in detail. The reality with the on-site measurement of stiffness is it's really important before you move forward. It's essential that these materials are adequately compacted, as I say, at their optimum moisture. So you have to prepare the site for the next layer. And I mentioned there the lightweight deflectometer. So this is a bit of kit that you might see on site. This is maybe about 10 years ago. This test was done in the picture. But what we're looking at is now the next layer has been put in. It's a more regulated layer. It's probably a finer material at top surface. So you can use the Prima, the geophone, and measure the vibration through the surface, and that will give you a lot of information back. There's many different types of manufacturers. You might have heard of the German plate or the Dynatest. I think we'll get to the point later that there's an opportunity to get these all calibrated, and not just by the manufacturers, but correlated against each and every one, so you can get correction factors assigned. And the most common one is the Sweco Prima 100. We've got quite a few of them, as the other laboratories. And again, this is a point where you get a lot of data collection to say you can move forward. You're thumbs up, and you have confidence to use that site for higher stresses. There's also the important bit that the equipment has to be calibrated. The geophone and the rubber cones have to be looked at annually and inspected by the user quite regularly as well. Okay, so the lightweight deflectometer is a very discursive topic at the moment. There's a lot of people that are trying to understand it. They're trying to ask questions about it and understand why it doesn't work in certain environments under certain constructions. And I think that's the most important point, is that you have to understand what the construction is. If you've got a geogrid or a posi drain or some sort of horizontal drainage system that's different, or some sort of stabilization material, you need to understand that before you go to site and understand the material and the reaction it will give the machine. So the picture there is a German plate, one of the older machines and probably more used internationally. I suppose the point I'm trying to make is that it's very, very important that you understand the material and the applied stress you put under the LWD and the protocol you use. The protocol we use for the Prima it varied at the start of its use, and when it was brought into sports construction, we usually go for 3 seating loads at a higher stress, somewhere around about 100 kPa, and then we do a lower and a middle seating load somewhere between 20 to 70. The point of that is to stress the surface at different loads, and then what we do is we normalize it to 100 kPa, and that's when you get your surface modulus result. That's where that comes from. I suppose the idea here is that the plate at the bottom, you can see the diameter of the plate. You'll get an exposure depth interpretation of about 1.5 the diameter of the base plate. So if you've got a 300 mm diameter base plate, which we commonly would see in our industry, you're going to expose about 450 mm. So the geophone can probably accurately give you 450 mm. There is a waiver that you have to understand the material. Again, you need to know what's below it. If you've got a geogrid within that 450 mm, then you have to reevaluate how you're going to test that material. And I think the other point to make is that the effective surface foundation modulus is a great test, but we're still adapting to this in the industry. We're still learning, and the most important point is that the people that interpret the graphs are the most important people. Sometimes it's not just a number. This is an example report. It's not just a number that says pass or fail, although you can see in the report it says that. You need to understand what's happening with the curves in the graph, and if there's water retention, if there's under compaction, or if you're getting a good curve. So there's a lot more than just looking at the numbers, and I think that's the point in our industry that we need to accept, and we need to make sure the right people are looking at the graphs. And I think because we come from a civil engineering background at Sportstyle with chartered engineers, we have the backup of people that work in the highways and road construction industry. we're very confident in our results and assessment of the situation, and that's where we need to move into, that everyone's confident with the results and the interpretation of the graphs. The other good thing about the LWD is that the graphs can be sent directly from Site Live, so you can get very quickly a feedback to the contractor or to your client that the site is performing well. And likewise, if not, if you do 21 locations and 7 of those locations have problems, then you can then start to remediate and put an action plan together to fix that. Sometimes the contractor might think that you can drive across the site and there's no evidence of any movement, but if in that case we need to look at the material in more detail. So the reason that I mention that is because we are talking about research on the LWD correlation. There's a lot of different equipment on the market at the moment in terms of what labs are using and the methodology they're using. I'm talking about globally, not just in the UK. And luckily we've done a lot of research with the agencies in the civil and road construction department. And what we're looking at is we're trying to find out if these machines actually are given correlation between each other and they're given consistency. The good news is the findings were there was a lot of consistency, but there is correction factors that should be applied to certain bits of kit. And that was the first one we ran last year. It was a great session. We had a lot of people at it. There was some very, very experienced people, and there was some less experienced people that learned. And I suppose the point is that we're still evolving. We're still understanding how we can use this equipment in our industry. So we've now got a test bed that we can use going forward. We did site tests and we did lab tests and site tests, and it allowed us to look at how people use the equipment and try and modularize that process. Unfortunately, there's very, very few test beds for this type of program. We will ramp it up in the future, and it's a great opportunity for people to have confidence in the test results. And you can see a picture at the bottom how many people turned up with the different types of kit, and the spread of results across. It's a great report put together by Michael Gordon and WSP, and at the site we had 28 LWDs. We had 2 GDPs and 2 FWDs. The FWDs were the big bits of kit that we will try to normalise it against, and that's something that we did on the day, so we could have some confidence in the comparison to a bigger bit of kit. So we'll talk about the drainage channels, why that's important, what we do on site. What we're looking at in the drainage channels are simple things like the dimensions, the slope, the centres. Is it to design spec? Are they wrapped in geotextile? Is the outflow connection? I suppose as well, not just is it pipe? Is it perforated piping? Is it going to work? Essentially, it's some very, very practical tests and assessments, but sometimes these things can go wrong, and you can't just dig it up and fix it as easily as that when the carpet's down. So quite an important site visit. Sometimes not done by us, sometimes done by the contractor and evidence provided by the contractor. Again, but some people want the independency for it to be done. And you can see as well, we look at the depth of the channels and the material used. So the type of pea gravel or trench backfill that's used. Is it porous? Is it going to block? These are the type of things that we want to know. We can also look at the layer depth, so the actual material on site. There's obviously discussions about compacted or uncompacted stone and the voidage percentage. Well, I suppose if you're paying for 250 mil of stone, you want to know you're getting 250 mil of stone, and a level assessment and having someone to come out and independently check that's quite important as well. So as a contractor as well, you obviously have your weigh bills and you have your lorries that come in, but sometimes there's a disconnect between the layer thickness and the material brought to site, and it's not always a contractor, it can sometimes be the type of material. And I suppose when we move towards, we're getting closer to the carpet, we're looking at water infiltration and how water infiltration is affected by different types of materials. Finer materials, blinding materials at the top, these tend to close the system. Sometimes systems are designed to be non-porous, So, for example, we just had a conversation in Italy. They use a Spraycrete or a MAPE system sometimes, and these systems are designed to be non-porous and they'll have a horizontal drainage layer above. But if it's not and it's designed to be porous and the water can't travel, then we essentially have problems, and big problems. We have you have a slope on a pitch, but you still need to have vertical percolation. And I suppose once you move from the sub-base and you move to the carpet, you can see some ponding on the pitches. There's a lot of pictures you can pick up online, but some of the extreme cases, if you have really high storm damage and the water can't move, can't travel, then the carpet can walk, the infill can walk, and you can end up in very difficult positions as a facility owner, like we can see in the picture. There is a EN 12616 method that is very much used. There's a bucket test that's used as well in different countries around the world. The point, I suppose, here is that it's very difficult to control lateral water flow when you're testing a base. So you have to ensure if you're doing one of the methods that or the 12616 method, that you prevent lateral water flow. Surface evenness check. So what you can see in the picture here is the roll and straight edge. So we came up with this design and the equipment, and the reason for that was the box straight edge would drag along a stone surface. So the roll and straight edge allows the test to be done easily on quite mobile or final layer stone. And sometimes before the blinding layer as well, you can do it. And it's a good test. It's very simple. You do it laterally and longitudinally. We would always advise people to do both. Sometimes it's done longitudinally only. Different tolerances for different sports. Football we tend to work, and rugby we tend to work to 10 mil tolerance. Some other sports can go down to 4 mil or 6 millimeters. So knowing the end user and the application of the surface is important to what tolerance you're wanting to apply. Okay, sampling tests. So we talk about taking samples from site and what we do with them. So we look at the carpet, we test loads of different things on the carpet, from the infiltration of the carpet alone to the tuff withdrawal, quite a common problem. The identification in terms of the tuff numbers, the stitches, the gauge. Visual inspection. A visual inspection is very powerful on carpet. You can always see if there's not enough latex or PU applied to the backing. So as experienced eyes, it's good to have those samples and get feedback. And sometimes as a consultant, you might be representing the buyer, and it's important that they know what they're getting is as designed and spec'd. The seam test. Every day of laying, the seams should be tested. So glue reacts differently in different temperatures and different climates and different moisture. So taking samples and getting them tested in the lab. There is a curing time, so we apply the curing time if we get negative results or non-conforming results. And again, with the sand and the rubber, performance infill and stabilizing infill, shape sand density is a material of the right standard to percolate water, to perform in the right way, to meet the grading within the FIFA World Rugby Report or FIH report. It has to be within tolerance for shape and size and density. So it's good to know if that's wrong at the start. If not, you'll have a delay. You might have to do an updated lab report. And now as well, with performance infill, you have to do a TGA, which is a thermogravimetrical analysis on the rubber. And the TGA is done to ensure that the organic and inorganic compounds in the materials are similar. So if you have a higher elastomer or percentage or a higher inorganic compound, then the material will perform differently over time. Okay. Aggregated material as well. It's a good point to make, is that you've got stone material on site, and I think it's important that you know that the material is what's in the design specification, so that can be done. And finally, the shock pad. So you take samples of the shock pad from site. You actually have to do this for governing bodies if you're reusing a shock pad, and there's again a descriptive graph or chart there that can tell you what you have to do for different sports. And we would take samples from site and give you back tensile strength, thickness, elongation results. There's also a requirement with some governing bodies to have your shock absorption and your deformation tolerances within what's declared in the FIFA World Rugby Report. These are all tests that can be done on site, and I suppose the big question is, how often do you do these tests, and how much does it cost, and where do you do them on site? Well, I suppose the first thing to look at is the cost. The cost is like a key stage inspection. It's one person on site a day. every lab's got a different price. It depends where the site is, so you need to go case by case. In the UK and Ireland, you know, you're not an expensive. It's not an expensive process to do. It's very common for people to do it. You know, we, for example, have 5 teams on the road up and down the UK weekly. So as long as we get the knowledge of where the site is, we can put it in the testing plan. In terms of what we do and how many locations, this is very rudimental in what I would propose. But with the stability checks, you're looking anywhere from 300 to every 500 square meters. So your minimum probably want about 15 per site and up to 25. If you get a non-conforming result, then you start to test a lot more in that location to try and understand the range of the problem, and I suppose understand what's going on. Infiltration, similar. You probably don't want to do as many tests, probably up to every 1500 square meters. It's quite a laborious test if you do it properly, and it's an important test. Even this full area, I talked about longitudinal and lateral. You want to do both directions. Quite commonly, people only do longitudinal, but I would suggest that everyone does it in both directions. And the layer depth, particularly on when you get to an engineer layer, it's maybe a bit more difficult, but when you're doing a stone layer, having the access to equipment on site to dig or to manually get down it might reduce the number of tests you want to do. Slope 10 by 10 grid, sand and infill on site, you're looking at 1 kilogram during the inspection. We'll take more during the FIFA certification test, usually 6 different locations, a kilogram each. And the shock pad for everyday laying, you're looking at 300 by 300 mil samples, and we do 6 dumbbells at each sample for tensile strength. It seems every day of laying is mentioned, and the carpet you're looking at a 1 by 1 square meter sample, and we want to check the line colours as well on the yarn. And again, we would take samples when we're doing the certification test. So just finally, I want to point you in the direction of our technical newsletters, and what these, if you ever have a specific question, you can sometimes get the answers in these. We're always contactable. We're always there to answer questions and help find solutions. We kind of pride ourselves on that if we can. So use the platforms freely and openly. I've put a couple in here that already apply to what we've talked about today, so that the design from the ground up, what lies beneath, the reuse of shock pads, the LWD and the lightweight deflectometer. So again, thank you for listening. We've got a few people online today from Sports Labs. We've got Joe Meller, who's a site technician based down in England, and Joe will be on site doing the tests. We have David Dickinson, I think, as well from the consultancy department. So we're open to an informal discussion and questions. So please fire away. And what I'm going to do is I'm going to unmute everyone so they can chat.
Before we kick on, it's David here from the consultancy department. I just want to summarise a few points from my perspective here. In terms of the costs, we're talking around about 1% in a lot of instances to do key stage inspections of the total project cost. So it really isn't expensive. And what that actually does is reduces the external fees for consultants or different people to come onto site to check different bits and pieces. But it really is health and safety, design and quality assurance that you're looking at here. It gives everybody the comfort and reassurance that the project's running correctly, and it's really the interest of all parties. So you've got the client having an interest in this. They want reassurance. Consultant, same idea, reassurance, making sure the design's right. The contractors demonstrating continually that they're meeting the quality required. And then you've got the manufacturer that who's providing the system, just making sure everything's happening the way they would want it to be. So that's my 50 pence. And as Neil says, open to any questions.
Yeah, good point, David. I think when you talk about the cost to do it, I did a recent survey, and when you're looking at a resurface, you're looking at up to 1% of the cost. If you're looking at a new build, then you're down at 0.5%. So it's a very small number to pay for some really strong evidence of base and construction design in the right way. Okay, so we're gonna jump to some questions. So Arno's asked for the handouts. Will they be available? Yes, there's a recording, so we'll make the recording available, and we can share the presentation in PDF format as well. He's also asked, what is your experience with horizontal water flow based construction methods? Interesting question. every country from South America, we talked about Italy earlier on, all different designs. So I suppose we do have a lot of experience, but every design is different. I suppose if you want to be a bit more specific about the type of design or product, Arno, we can really look at investigating it and its capacity and its ability to hold water and not just dissipate the water. Some of these horizontal drainage systems are designed to retain the water, and there's many reasons for that, from keeping the surface temperature down, and I suppose that's what we could discuss further. Okay, we've got a question in from Ross. Everyone's unmuted, so what you can do is you can also ask questions verbally. You can unmute yourself and pitch in. Okay, so Ross has asked, where in some larger developments clients sometimes undertake the formation phase 1 outside our framework and then hand over once the footprint has been established. Is there any advice other than to achieve 5% CBR to ensure a smooth handover process? David, you might want to jump in on this one. You're from the consultancy department, because you work on a lot of projects out with big frameworks as well. And I suppose, Ross, there's always that bespoke nature of every project. In terms of to achieve a smooth handover, there's always the communication with the client. If you don't get a result, then how do you accept it if you can't remediate it? And that's where the engineering decisions come in.
Okay, Neil, I'm struggling to see the question. Can you go through it again?
Yeah, so basically Ross has asked, where in some larger developments, clients sometimes undertake the formation phase 1 outside our framework and then hand over this footprint once it's been established. Is there any advice other than to achieve 5% CBR to ensure a smooth handover process?
Yeah, I've seen that quite a lot, where it's a larger project, as you said, and there's a bit of enabling works and they'll hand over a platform. I think it's important that everybody at that point gets round the table, that both parties do some testing of that surface, or at least or they both appoint the same person to do it, and you get the testing done thoroughly. And then if that then indicates that you need to do additional work to achieve your 5% or achieve the design that you've put forward, or if it means you have to do more additional work, then I think everybody needs to sign up to that at the start before you accept the platform itself. Different clients have different takes on it, and especially if you're working for a main contractor, that can become a problematic discussion. But I think you've got to be resolute and protect yourself in that scenario as best you can. There's obviously some materials like geogrids and lime stabilisation which will guarantee your CBR. So there's plenty of design techniques, but you just need to make sure that's all on the table at the start.
Great. Yeah, I think. Okay, I'm not sure if everyone had technical problems that I picked up intermittently there, David. What percentage of pitches do not have process testing in the UK? There's quite a big framework in the UK, not just in England, but in other countries, that they tend to adopt the testing. The consultants are very aware, so there's quite a high percentage that adopt the key stage inspections, Arno. There's a lot of countries that don't. Some of the Nordic countries last year we worked in, they started to do some of the testing, which is great. But it's something that's awareness in certain continents around the world is sometimes limited. So spreading the message and letting people know that it's available to be used is very important.
Yeah, Arnold, for me as well, I think it depends on how the project's been procured or tendered. If it's a design and build, then I mean the good contractors will carry out the key stage inspections and testing as part of that process to protect themselves, whereas some of them might just go ahead on their own merit and hand over a pitch that they're happy with, you maybe just supplying a lab certificate or a technical data sheet to say that it's conforming. So it just depends on how the project's arrived.
Yeah, I think the next question we've got here, David, is from David Viney, and David asked us, what's their experience of in-situ shock pads being laid directly onto G5 over the long term? A very interesting question, David. We've seen it, and we've also seen problems from this. So I think, David, have you had any consultancy projects that have done that?
We tend not to. We really tend not to. What we're seeing more often is like an ET layer, you know, a mixed rubber and gravel that going directly onto it, but tend not to go. We tend to not put any in situ directly onto that type of base ourselves. Neil, we've probably inspected a few over the years, but we don't design that way.
Yeah. Okay. Okay, I think we've covered the questions. Has anyone got any more questions or want to unmute and have a discussion? By all means, please feel free. We always try and be as open and discursive as possible, healthy, constructive discussions.
Yeah, Arnold here.
Hi.
Hi. Just a question. You see more and more regulations from FIFA and FIH go to result testing instead of process testing. Is this contradictory to what you want to offer, or how do you see this? How do you position this service?
I think if you look at the governing bodies, what they're looking at doing is they're looking at the final surface, and it's very, very difficult for them to control all the layers and the construction process. And a lot of the time, it comes back to knowledge and expertise as well. And some of the bigger frameworks, for a lot of technical expertise, and that they know the problems, they've had experience with the problems. So, from the point of view of a governing body, they want to represent the final surface. They're only interested in the final surface a lot of the time, and that's where the consultant is very important, and the process control, because you're, as a client, want a long-term performing base. You want to have a resurfacing a model, and sometimes that is not easy for a governing body to control or get involved in. So it's slightly different, I suppose, expectations from a pitch.
The governing bodies or regulatory bodies that set up like FIFA or similar, I suppose they are trying to make a one-size-fits-all specification. And the one thing that's sure is that everywhere in the world is going to be different from the ground down. The base is going to be completely different. There's all different techniques. So that's where, as Neil said, the design for that base is so important. And a lot of these key stage inspections, as I said, can really help either investigate the existing ground or be used in the construction process to reassure everyone that the bases are built correctly.
Yeah, I think there's a very good point that comes from Walter in Ireland, and David and me have discussed this quite regularly. It's about design and build, and I suppose the liability and risk for contractors, and that's where someone independently providing a report can give them evidence in the future. They can have I suppose a portal where they have all this evidence and information to look back at. And sometimes, you know, when it's a design and build, it's a price competition rather than a quality evaluation, tender evaluation. So it is really important when you start to go down the route of design and build and the liability and risks that you really consider this as part of the process.
Isn't it so that all the FIFA preferred producers are taking liability for the job their contractors are doing?
Yeah, as soon as they go to site, as soon as they lay carpet, then they take on the liability of the base. I think that's with the preferred producers.
So that means basically that's from a commercial point of view, those should be your first clients, because that will give them the security that they uphold their promise to FIFA.
Of course, Arno, you're correct. The only problem is that when it comes to price evaluation and not having knowledge, if you consider places like Africa and Asia and South America, sometimes the knowledge of having key stage inspections and specific to sports construction is limited. So they don't have that information available to make the decisions. And sometimes when a preferred producer or a licensee goes in with a very robust and long-term plan and something that will score very high on quality, it's overlooked. And it's the challenge is for us as an industry to be very communicative and share what can be done. A lot of these tests, can be done by us. They can be done by local civils labs, so they're accessible. They're not restricted to one lab or to one industry. They're basic civil engineering tests and practical visual assessments on site.
The other thing for that, Arnold, was to do with the final surface. Evenness. If evenness becomes a problem, or if there's any failures to the base, then I'm pretty sure the FIFA licensee or whoever lays the synthetic turf can't be held responsible, and they'll fight tooth and nail that it's not their responsibility for failures in the base. But they just need to be clear in that, and that's where it'd be good even if they off their own back had the existing base that they've presented, tested or checked to meet the requirements before they start.
Clear. Okay.
Walter, just in response to yours as well, we see quite a lot of that in Ireland with the design and build projects, where clients, clubs get a cheap price, and then potentially we're appointed somewhere down the line, and hopefully, if that is the case, we try and make it a bit more robust in a design and make it equal across the board, so it can be priced from different contractors. But sometimes we're too late, or we don't get in, and they do get built by the contractors direct. And sometimes they're good and fine, and in other cases it can be a horror show.
Yeah, from firstly, just to yourself and to Neil, congratulations on the webinar. Very informative and interesting topic, so fair play. Yeah, just on the we see from an NGB point of view, a lot of clubs or clients that we class them as, they come back with reports that they've done their tendering process, and they're going to award it to the cheapest tender based on how attractive the price is. Now, with experience, you'd see down the line that the price may have been a little too cheap, because the impacts of the carpet or the drainage, which you can't see from a visual, the drainage impact down the line is very visible well after the contractor is being paid and has left, and the retention period is expired. So from NGB point of view, we try to push out the product quality rather than just the price, because you end up with a situation where you're crying twice. The first time when you have to pay over a large sum of money for these pitches, and the next time when you need to rectify the problems when the contractor has left. So we're just trying to educate our clients, our clubs, to say that, number one, cheapest isn't always best, and number two, look for third-party consultancy advice down the line when you're doing the tendering process, rather than just taking up this large project as a solo run within the club. Because I asked many times, if you were building your house, would you go off and spend the same type of money building your house with zero expertise input? And the answer is always they would never do it. And I say always use this concept for building an artificial pitch.
Well, that's really key for me. We're banging the same drum, obviously, from a commercial point of view, but as well as quite often a lot of funding that's issued to clubs, and a good example is in Scotland, where Sport Scotland would issue funds to clubs to build their pitches or whatever, but they would condition the funding to say that they can't go ahead with their actual build without the involvement from a recognised pitch consultant and built by a recognised pitch contractor. So I wonder if there's any way you guys could pressure a similar condition to protect your investment, because, as you say, the other thing is we quite often encourage clubs to use people who they have within their club to their benefit. If they've got an architect who's working for as part of one of the teams or whatever. There's no reason that can't happen. It's just this specialist involvement somewhere down the line just to keep them in the right direction.
Well,
David,
from experience, we have the exact same, not issues as such, but we've a problem where we do grant money, or we had in the past, and we granted support for some of these clubs nationwide. And it was because of resources. We couldn't go after every single one of them and ensure that they did X, Y, and Z. It was all done in good faith. But going forward, it's something that we will look at to make it a condition that if we were to do any sort of grant support or fund aiding, we would ensure that they would comply with our standards. We have one in FAI, it's called Club Mark. It's an excellence of your club. And there's a box ticking exercises for all different sorts. And we'd like to do something similar, that if you were to get a grant down the line, you would have to ensure it was certified, it was continually inspected, like you're mentioning here in the KSI sections, and artificial or even natural turf pitches or even floodlights, there should be sign-offs if funding is granted, if NGB or even government funding is provided. In an ideal world, obviously it's a lot trickier when you're actually practically doing this exercise.
Yeah,
as David, you did a presentation at SAPCA last year, and I remember the title was Race to the Bottom, and it really challenged everyone. Is when you're doing tender evaluation, do you even consider quality? And it's a question as an industry we need to ask. It really is, because we do have a lot of innovation in the industry that's coming because of environmental protection, and we don't want to prevent that from coming into the market and stifling innovation because of the race to the bottom.
It's what you saw in Holland. Because Holland already has process testing obliged for the last 30 years, I think. But it also stifles innovation to a large extent. So with giving up the process parameters and starting focusing on the result, while still paying attention to the underlying parameters like you do here, it gives more freedom to innovation. So I think the focus on the result is good, but like you said and like you pointed out, the history of especially the problem with the unbound bases in countries where there's not much expertise in building those bases, there's a huge amount of problems, and that's where the process testing comes into place. From the one hand, I think innovation from the other hand comes into place. So I'm very keen to learn what you think of the next webinar that we do.
Yeah, I've seen it. Arno, you're doing some very good webinars as well, so congratulations. I think
no, it's joint. It's the new way of communication, and I like it. I see my wife more. I'm not sure if I like that, but let's not get into that discussion. It's not for this not for this webinar.
You're about to be muted. No, I think if you go back to the point about engineered bases, we always push engineered bases on site, and the reason for that is because of the long-term asset the pitch then becomes and the ease to resurface. But David pointed out regularly they're value engineered out the project. So where does it sit in the priorities of the club or the financer? Okay, guys, have you got any more questions? Any more discussions?
No, apologies for being late. Look forward to the handout.
No problem, Arno. Take care.
Okay, take care, guys. Thanks.
Yes. Okay, thank you, everyone. The webinar will be available for everyone we can send you the link to watch it again, or the presentation slides if you want them. Please just get in contact. You've got David Dickinson at Sports Labs Consultancy. You've got myself at Sports Labs, and we're contactable on the phone or by email. Okay, cheers everyone. Stay safe, and we'll see you when traveling is allowed again.
Thank you.
Thanks,
Bye-bye.
guys. Thank you.
Thanks, folks. Good seminar.